In the dark heart of the universe, a star dies, and something monstrous is born. A neutron star, what's left behind when a massive star collapses under its own gravity. It's no bigger than a city, yet heavier than the sun, and it spins with unimaginable force, pulsing like a cosmic lighthouse. These stellar corpses are some of the most extreme objects in the cosmos. But what if they're more than just space oddities? What if we could actually harness that raw, cosmic energy, millions of times more powerful than anything we've ever produced on Earth? Could neutron stars become the ultimate power plants of the future? And here's where it gets even more mind-bending. What if we're not the first to think this? Somewhere out there, could advanced civilizations already be tapping into these stellar beasts, using them as galactic batteries to fuel technologies we can't even imagine? In this video, we're diving deep into one of the wildest what-ifs of astrophysics, using neutron stars as power plants. We'll explore the science, the tech, the nearly impossible challenges, and the tantalizing possibility that someone out there might already be doing it. Before we can plug into one, we need to understand what we're dealing with. Neutron stars are the crushed remains of massive stars, so massive in fact that they die in supernova explosions, collapsing in on themselves with such force that protons and electrons are squeezed into pure neutrons. What's left behind is a sphere only about 20 kilometers across, but with more mass than our Sun. That's like compressing Mount Everest into the size of a sugar cube. Gravity here is so strong, it warps space and time. A single teaspoon of neutron star material would weigh more than every car, truck, plane, and building on Earth combined. But they're not just heavy. Some spin at hundreds of revolutions per second. Imagine a whole star rotating faster than a blender. These are pulsars, shooting out beams of radiation in perfect intervals, like a cosmic clock. Others are even more intense, magnetars, with magnetic fields trillions of times stronger than Earth's. They could wipe your credit card's data from thousands of kilometers away, and maybe your brain too. In short, these aren't your average stars. They're nature's most terrifying batteries, violent, beautiful, and unbelievably powerful. Which begs the question, what kind of energy are we talking about here? Let's talk numbers, because the energy neutron stars hold isn't just impressive, it's terrifying. A single neutron star can spin over 700 times per second, like a cosmic drill bit. That rotational energy alone is mind-blowing. Some pulsars emit beams of electromagnetic radiation so powerful they can be detected from thousands of light years away. And remember, that's from something the size of a small city. Now picture this. Just one of those beams could output more energy in a second than Earth uses in an entire year. Let that sink in. While we're here struggling with fossil fuels, power outages, and fusion dreams, these things are casually throwing off unimaginable amounts of energy into the void. But there's more. Neutron stars have gravitational energy that's off the charts. If you could somehow build a platform to orbit one safely, the gravitational potential between orbits could be used to generate energy far beyond what any hydroelectric dam could hope to match. And if you're thinking that sounds like science fiction, you're right. But it's grounded in real physics. The math checks out. The theoretical energy locked inside a neutron star's magnetic field, rotation, and even crust vibrations could make our most advanced reactors look like campfires. Here's a fun comparison. The entire energy consumption of human civilization is around 600 exajoules per year. That's a 6, followed by 20 zeros. But a fast-spinning neutron star could crank that out in minutes. So yes, the power is there. But how would we even begin to harness it? Alright, so neutron stars are basically the universe's ultimate power outlets. But plugging into one, easier said than done. Let's say, somehow, you arrive near a neutron star. What now? Option 1. Pulsar beam harvesting. These beams of energy shoot out from the star's poles, and if you could position a massive energy collector, think giant orbital solar panels, you might capture some of that radiation and convert it into usable energy. Of course, you'd need materials strong enough to survive radiation that would fry a spacecraft in milliseconds. Option 2. Gravity power. Orbiting a neutron star would feel like riding a roller coaster on steroids. The intense gravity could theoretically be used to extract energy, maybe by tethering massive structures and converting orbital momentum into usable mechanical or electromagnetic power. Option 3. Magnetic tap. Magnetars have magnetic fields a quadrillion times stronger than Earth's. If you could get close enough without being turned into subatomic spaghetti, you might use these fields to induce enormous electric currents, like a cosmic dynamo. There are also ultra-speculative ideas like building a Dyson sphere, but instead of surrounding a sun, you wrap it around a neutron star, or creating plasma conduits that siphon off the star's energy from a safe distance. Sounds absurd. Sure, but so did flying once. The biggest problem? You need tech that doesn't exist yet. What could go wrong in this fun little project? Spoiler: everything. Neutron stars are not safe to be around. They're basically death traps wrapped in gravity and gamma rays. The surface gravity is so intense, it would crush any spacecraft like a soda can. Then there's the radiation, enough to cook anything that gets too close. Oh, and the magnetic fields, strong enough to shred atoms apart. One magnetar's magnetic pulse could wipe out every hard drive on Earth from a distance of over 1,000 kilometers. And let's not forget relativistic jets. Some neutron stars blast particles at near light speed. If one of those beams hits you, it's game over. You wouldn't even see it coming. Now imagine trying to build a power plant in that environment. You'd need materials that can survive a direct hit from a star quake or a gamma ray burst. You'd need AI, drones, shielding, and tech that could laugh in the face of extreme gravity and magnetic annihilation. And even if you could survive all of that, there's still the problem of distance. The nearest neutron star is over 400 light-years away. Not exactly a quick commute. So, why even bother? What could make us, or anyone else, take on a mission this insane? Here's where it gets juicy. According to the Kardashev scale, a Type 2 civilization can harness the full energy of its star. A Type 3, an entire galaxy. So, what if neutron stars are their version of power outlets? Some scientists have actually suggested that pulsars could be used as interstellar navigation beacons, galactic GPS systems, possibly set up by advanced civilizations. Why? Because they're predictable, powerful, and stable over millions of years. And then there are anomalies, pulsars behaving in weird, inconsistent ways, skipping beats, dimming suddenly, or radiating in unnatural frequencies. Most of it's probably explainable, but some of it still unknown. The idea that aliens might be tapping into neutron stars isn't as far-fetched as it sounds. If you're an advanced civilization needing a ridiculous amount of power, why not go straight to the densest energy sources the universe offers? We search for signs of life around sun-like stars. But maybe, just maybe, we're looking in the wrong place. maybe we should be watching the dead ones. All right, back to us. Could we one day become the kind of species that plugs into neutron stars? It's not impossible. If we develop interstellar travel, materials stronger than anything we've ever made, and AI capable of surviving cosmic hellscapes, then sure, maybe we could build orbital collectors or power stations near neutron stars. We'd need to master nuclear fusion, quantum shielding, and probably invent new physics along the way. In some far future, we might not even need the whole neutron star, just a way to stabilize and miniaturize a portion of its power. Maybe we'll carry tiny fragments aboard starships as portable reactors. Or maybe we'll create artificial neutron matter in labs, opening up a whole new era of ultra-dense energy sources. The tech is out of reach for now. But remember, there was a time when flying to the moon sounded insane. Now, we're planning missions to Mars. Let's be real. This isn't something we'll pull off next week or next century, but the idea matters. Why? Because thinking on this scale expands our imagination. It pushes the boundary of what's possible. It dares us to look at the most violent, dangerous objects in space and ask, can we do something useful with that? Even if we never tap a neutron star, the journey toward understanding them will lead to new tech, better science, and maybe even answers to bigger questions, like whether we're alone. And if one day we spot something strange near a pulsar, some odd signature, some energy dip that doesn't quite add up, maybe that's the day we realize we're not the first ones to try. Neutron stars are terrifying, but they're also beautiful. They're remnants of cosmic death, yet bursting with potential. Could they be the future of power? Maybe. Could someone else already be using them? Now, that's the real question. Thanks for watching. And if you enjoyed exploring this wild possibility, don't forget to like, subscribe, and share this video. The universe is full of secrets. We're just getting started.